Hello, good people. Welcome to Memos Tutorials. Today we are looking at the periodic table. So we need to be able to describe the periodic table as a method of classifying elements and its use to predict properties of elements, right? So the periodic table is used to classify elements by placing them in groups. Elements whose atoms have the same outermost electrons are placed in the same group. So what does it mean? When elements have, let's just say elements with one electron in the outer shell are all in the same group. All of them, as long as they've got one electron in the outer shell, you'll be in the same group. Elements with two electrons, they will also be in the same group. 3, 4, all the way up to 8 electrons in the outer shell, right? So we are saying they are also arranged in periods. Periods are rows. So rows in the periodic table, we call them periods. And then columns in the periodic table, we call them groups, right? So we are saying elements with the same outermost electrons, they have the same or similar chemical properties, right? So for example, group 1 elements react similarly with water to form hydroxide, right? So when we say group 1, we're just referring to the first column, right? So now we need to be able to describe the change from metallic to non-metallic character across a periodic table. I'm sure you can see I have blue color for metals. I've got green for metalloids. Metalloid simply means you are in between. You are not a metal, neither are you a non-metal, so you are in between, right? So now looking at this, we have the first column here. On our first column, we have only one thing, only one element that is not a metal. Otherwise, all of them are metals. And what's the name of the element? H, that's hydrogen, right? So you also need to know H stands for hydrogen, right? So as you can see, apart from excluding hydrogen, all elements on the left side of the periodic table are metals, right? And then as you go to the far right, you start getting your metalloids, the ones that are green. You start getting them, and they're in kind of steps, starting with boron there, going all the way to PO, there's TE there, and AT at the bottom there. So now, what we have above the metalloids are nanometals, the one that you see in yellow. All these are nanometals that are on the other side there, right? So now you just need to be able to tell us what those if it's Li, you should be able also to tell us that that's lithium, right? So now the next part, now we should be able to describe and explain the relationship between group number of outer shell electrons, and metallic or non-metallic character. Already you have seen that the left side of the periodic table we've got metals, and on the far right we've got metalloids, which are semi-metals, and then on the right side, that's where we have nanometals, right? So I've got some elements here where they want us to they want to show us the relationship between number of shells and the period number, right? So now we have helium with only 2 electrons. So helium, where do we find helium? Period 1, and then it has got one shell. Where is helium? Let me show you where helium is on the periodic table. So helium, it's He. There is helium. And the first row, this first row is the first period. Then the second row, we call it the second period, right? So helium is in the first period, and it has got only one shell. What do we mean by only one shell? Remember, it has got only 2 electrons. So those 2 electrons, they are only in one shell, right? And then when you go to sodium, which is Na, sodium, it's in period 3, and it has got 11 electrons. So the 11 electrons, they require 3 shells. Remember the first shell, when we spoke about the subatomic particles, the first shell gets filled with 2 electrons. It doesn't take more than 2. The second shell gets filled with only 8 electrons. It doesn't take more than 8. So automatically, if you have got more than 10 electrons, they overflow to the third shell. That's why sodium has got what? 3 shells, right? and then we get it in period 3. Magnesium as well, it has got 3 shells because it has got 12 electrons, so 2, 8, 2 in the outer shell, and also it is in period 3. Lithium, it's in period 2 and it has got also 2 shells. So can you see the relationship now? The period that you are in determines how many shells you have. If you are in period 1, it means you have 1 shell. Period 2, you have got 2 shells. Period 3, you have got 3 shells. Period 4, 4 shells, going down like that, right? Now let's look at group properties. So we need to describe lithium, sodium, and potassium elements which are in group 1. So we want to look at them as a collection of relatively soft metals showing a trend in their melting point, the density, and also their reactions with water. We also need to predict. All right, so now looking at elements in group 1, these elements in group 1, they are known as alkali metals. So we know them as alkali metals. So the atoms of these elements, they all have 1 electron in the outer shell, right? These metals are soft and can be easily cut with a knife. They are very, very soft metals. So these metals, they show a certain trend. They have a pattern in their melting point, in their density, and also in their reaction with water. So as a combined science student, you are expected to be able to predict the behavior of each and every element in group 1 when given the behavior of other elements in that same group, right? So the first thing is, moving down the group, the melting and boiling points, they decrease, but then densities, they increase. Density increases as you go down the group, but then the melting and boiling points, they decrease as you go down the group, right? So moving down the group, we are saying the reaction of these metals with water increases, right? For example, the element lithium, which is above sodium and potassium in group 1, has a higher melting point and boiling point than potassium. It has a lower density than potassium, and it also reacts less with water as compared to potassium. So we are saying their reactivity with water increases as you go down the group, their density increases as you go down the group, but melting and boiling point decreases as you go down the group. Are we together? So the next group of elements are group 7 elements. These group 7 elements, we call them halogens because they are colorful gases and they are non-metals, right? So we have this group 7, we know them as halogens, like I've said. And another thing, they exist as diatomic elements. So there is fluorine there, it will exist as F2, chlorine Cl2, bromine Br2, iodine I2, right? So di means 2, right? So these ones, we find them on the right side of the periodic table, and they have 7 electrons in their outer shell. They need to receive 1 electron for them to form a full shell, or for them to have a noble gas configuration, right? So they also show a trend in their color and also the physical state. So for example, the trend in color is that the color darkens as you go down the group. For example, chlorine is yellowish green gas, bromine is a reddish brown liquid, and iodine is a black solid. It's like we're moving from gases. As we move from a gas to a liquid, the intensity of the color gets more. And then from a liquid to a solid, now the color gets even more darker. Yellowish green gas, that's chlorine, followed by a reddish brown liquid of iodine. And then, is it liquid of bromine? Yes. And then the solid iodine, which is a black solid as you go down. So we are saying the trend in physical state in that is that the elements change from gas, liquid to solid as we go down the group. Chlorine is a gas, bromine is a liquid, and iodine is a solid. And these guys are colorful. And also we need to know this state the reaction of chlorine, bromine, and iodine with other halide ions. So for example, halogens at the top of the group are more reactive than those that are below them. which means fluorine is more reactive than chlorine, and chlorine is more reactive than bromine. So if you react something like chlorine and sodium bromide, what's going to happen is chlorine will displace bromine from its compound and take its place, such that we receive our own bromine gas, our own bromine separately. So here is what I'm talking about. This is chlorine, which is more reactive, and with a sodium bromide compound there. So what happens is chlorine will remove that bromine and puts itself, because it is more reactive, and then we are going to receive bromine on its own there. Are we together? So we are saying chlorine can displace both bromine and iodine, and bromine also can displace iodine, going down the group like that, right? Iodine cannot displace either. It can't displace either chlorine or bromine because they are above it in the group, right? So now we want to predict the properties of other elements. We have elements in group 4. So to predict these, that's not 4. I know 1, 2, 3. V is 5. VI. So that's group 6. Yes. So to predict the trend for group 6 elements, we are saying we need to remember that halogens are non-metals, showing, so that's group 7, sorry, showing a trend of the color change and also the physical state. An element below iodine would have to exist as a solid as well. We also need to identify trends in other groups given data about the elements concerned. To identify the trend in a group, simply make sense of the pattern that takes place in the group, right? So we have transition elements. We have got noble gases that we are going to look at on our next lesson. We don't want our videos to be very, very long.